Alright guys, let's finish this off and do the free response questions. This first question, I'm definitely going to ask one like this. It says complete the reaction above, cancel all spectators. So aluminum foil reacts with the solution of copper sulfate. Okay. And what's going to happen in this situation is aluminum is going to be oxidized, copper is going to be reduced, sulfate's going to cancel. There we go. Write and balance the half reactions. Oxidation, reduction. Aluminum went to aluminum 3 plus, and it had to lose 3 electrons. Copper had to gain 2 electrons to be reduced to copper 0. Okay, when we look at this, we have 3 and 2, so the least common denominator between that is 2, and this is 3. So this is going to be 2Al goes to 2Al 3 plus 6 electrons, 2Al 3 plus, and this one is going to go to 3Cu 2 plus, 3Cu 2 plus 6 electrons goes to 3Cu 0, 3Cu 0, just balancing it. E cell equals negative E ox plus E reduced. The oxidized one was aluminum and the reduced one was Cu. So I'm going to look on my reduction potential chart, and I know that negative 1.66 volts is aluminum, and for the Cu2 plus going to Cu0, that's just going to be 0.34 volts. So when you add these all together, you get a positive 2.0 volts. Okay, let's think about what that means. It's a spontaneous reaction. Delta G is going to end up being negative. Delta G is negative NFE cell. There were 6 electrons transferred, so it's negative 6, 96,500 for Faraday's constant, and 2. And that's going to end up being 1,158,000 joules, which is 1,158 kilojoules negative. Is it spontaneous? Okay, spontaneous. Support your reasoning using the voltage and the free energy. Spontaneous, E is greater than 0, and delta G is less than 0. That's enough. Okay, convert this into a battery diagram. Label all the following. So, we know that we're going to have the anode. Okay, this is going to be made out of Al, and it's going to be the anode, and we're going to see 2 volts there, and that's going to be connected to Cu, and that's going to be the cathode. And this is going to be the direction that the electrons are going to move from anode to cathode. And each one is going to be immersed in its own solution of the spectator. So that it doesn't react with each side of the battery. Okay, I'm double checking if the spectator in this case was actually sulfate, and it was. Okay, so I'm going to put in the salt bridge solution to maintain electron flow. And by default, my cation is going to be Na plus, and my spectator ion is going to be the anion in the salt bridge. So I wrote the anode, I've done the cathode, I did electron flow, I did the salt bridge, I put in the metals, I put the solutions, and I put the voltage. That's a good problem. Okay. This problem is a very simple problem, actually. And what they ask you for is they give you a bunch of equipment here. Typical lab problem. And they say write the balanced net ionic equation for the reaction that would have the greatest positive voltage. So what we got going on here is we've got Al3+, we have Cu2+, and we have Fe2+. So if you look on the chart, okay, Cu2 plus is up here, Fe2 plus is here, and Al3 plus is there. That means the greatest difference would be between Cu and Al. So that's going to give you the largest number. There's the greatest difference in potential there. So really, so we have the NO3 involved. So basically, after you've done it and balanced it and the NO3 cancels, the Al is going to be the oxidized, the Al metal is going to react with the Cu2 plus, and this is going to go to Cu0 plus Al3 plus. You're going to have 2 here, you're going to have 3 here, you're going to have 3 here, and you're going to have 2 here. Now this is just like this problem, except for sulfate is the spectator instead of nitrate. So if you want to see this set up the other way, you know, it would be like saying Al0 plus Cu2 plus NO3 minus. That's really the way the reaction would be set up. Calculate the value for E cell. I'm going to say C1b. C for your response 1, part B. And it should be 2.0 volts. Alright, so in this problem, your instincts, I know, are going to be to put the 2 volts, to show the electron flow, to label this aluminum, to label this copper, to put in here the copper 2 plus, NO3 minus, to call this Na plus, NO3 minus. And actually, yeah, I mean, it's just, this problem is stupid easy. They're really, they say a cell is constructed based on the reaction in part A. Label the metal used for the anode. Okay, An-ox. We know that this is going to be oxed because it's lower. This is higher. And we know the cathode is always higher. So, there you go. For this answer, I'd like you to see AP problem 6 under homework solutions on the website. I actually have this broadcasted. I did it for one of my classes earlier. So see AP problem 6 under homework solutions on the website, and the solution for this problem will be posted. Okay, let's finish this guy off. Fluorine gas, Fe2, is bubbled into a solution of Na plus, I minus. So F is going to go down to -1, I is going to go up to 0, Na is going to cancel. You're going to end up with 2F minus plus I2. This substance is the reducing agent. That's the person who's oxidized. So the one that went up was I minus because it went from I minus to I2, 0. Zinc is placed in a solution of nickel nitrate. Nitrate's very soluble. Okay, zinc is going to go up to Zn2 plus, Ni is going to go down to 0. Nitrates are going to cancel. You're going to end up with Zn2 plus plus Ni 0. What is the voltage? So you do this calculation, and E cell is equal to negative E ox plus E reduced, which is going to be equal to a negative 0.76 plus a negative 0.25, negative 0.51 volts, or positive 0.51 volts. It's spontaneous, yes, because E cell is greater than 0. This next problem, aluminum. I'm going to stop this at 10 minutes, so if I don't finish the last part of this calculation, just refer to the solutions, okay? Al plus, Na plus, Cl minus, Al3 plus, it goes up, this goes down to Na0, Cl cancels, you have Al3 plus, plus Na0, that's going to be 3, 3, and we're going to be done there. Take care, guys. Peace.